In this video lesson, we're going to be solving a system of two equations by elimination. So we are going to eliminate one of the variables. So here's example one. We have these two equations that we're looking at. The first one, 4x minus y equals -1. And the second one, -4x minus 6y equals -34. Okay, so both of these equations have an x and y, and what we're going to try to do is to look to eliminate one of the variables. You'll notice there's a positive 4x in the first equation and a negative 4x in the second one. So if we'll just add these two equations, then it will eliminate the x. So I rewrote the first equation, 4x minus y equals -1. Then I put a plus sign, and I'll put a parenthesis around the entire second equation, -4x minus 6y equals -34. All right, so this means we're going to have 4x plus -4x, or the same as 4x minus 4x. Well, when you go to solve that, then the x's just go away. They canceled. But then the y value, we have a -1 plus a -6, and that's -7y. And then with the constants, we have a -1 in the first equation plus a -34 in the second one, which gives us -35. So we have added these equations and eliminated the x. Now we have an equation that we could solve for the variable y. We just divide both sides by -7 and y equals 5. Well, again, once you know one of the variables, you can substitute it into an equation to determine what the other variable is. So if we look at this first equation, 4x minus y equals -1, we're just going to replace this y right here with our 5. That's what I've done right here. So it's 4x minus 5. Should have put that in parentheses, but 4x minus 5 equals -1. Okay, then you just add 5 to both sides, and 4x equals 4. I didn't show that in the notes there, but 4x equals 4, and then of course you divide by 4 and x equals 1. Well, now you know the y value and the x value of the solution, and you write it as an ordered pair. The x is 1 and the y is 5. So we have solved this system of equations. We know that if you plug a 1 in for x and 5 in for the y, you're going to get a true equation where the left side equals the right side for both of these equations. All right, let's take a look at an additional example. Let's take a look at number 2. So in this one, the first equation is 10x plus 9y equals -17, and the second equation is 10x minus 2y equals 16. Well, now we notice that the x values are the same, 10x and a 10x. So if we're going to cancel those, we would have to subtract one equation from the other. So we're going to subtract the second equation from the first one. So here I've written it out. I've rewritten the first equation exactly as we see it. Then I put subtract or minus, and then in parentheses, I put the entire second equation. So now when we go to do the subtraction, it's 10x minus 10x, which cancels the x variable. But then we have a 9, and be sure you pay attention, 9 minus -2y, which really makes it 9 plus 2y, because minus a negative is positive. So this 9 minus -2y is 11y. And then here in our constant, we have -17 minus 16. And that's actually -33. So 11y equals -33, and then you divide both sides by 11, and you will see that y equals -3. So we have solved for y. Now we can plug the y value into one of the equations to determine what the x equals. So here I chose the first one, 10x plus 9y equals -17. So it's 9 times the y value. So in parentheses, I put the -3. So now it says 10x minus 27, because 9 times -3 is -27, equals -17. I'm going to try to isolate my variable x, so I add 27 to cancel it here. I add 27 over here to keep it true as an equation. And I notice that 10x equals 10, and then I divide by 10 on both sides, and x equals 1. So now in step 4, I write my solution as an ordered pair. where x is 1 and the y is negative 3. All right, one last one to look at here. Okay, so here is our two equations for number 3. We have a negative 3x minus 2y equals negative 6, and a 7x plus 6y equals 26. Now, this will probably be the most challenging one because you'll notice that there's nothing set up for the variables to cancel each other out. Okay, we can't add to cancel a variable, and we can't subtract to cancel a variable like we did in examples 1 and 2. But what we can do is we can multiply one of the equations to create elimination. So if I have a positive 6y in this second equation, I need this to be a negative 6y. Well, if I have a negative 2 and I multiply it times 3, that will make it negative 6y. And then I will see I have a negative 6y and a positive 6y that will cancel if we add them. So we're going to start with multiplication. I'm going to multiply the entire first equation by 3. So I have it in parentheses, 3 times negative 3x minus 2y equals negative 6. And then I just keep the second equation the same, 7x plus 6y equals 26. So as long as you multiply one of the equations, multiply all of the terms by the same number, then it really stays the same equation. All right. So once I've multiplied, you see my two equations now. We have a negative 6 and a plus 6y. This takes us back to our first example where we can add the second equation to the first in order to eliminate a variable. And the variable that's being eliminated is the y. If you look at the x, we have a negative 9x plus 7x, which is negative 2x. The y's cancel, equals, and then negative 18 plus 26 is 8. And then when you divide both sides by negative 2, it should say negative 2 right there, we get x equals negative 4. Be sure that's a little mistake there. Negative 2 divided by negative 2, I didn't write that in, but the x does equal negative 4. Okay, then again, once you know the variable, you substitute it into one of the equations to determine the other variable. So if we know x, we can determine y. So here I've done that. I've picked the first equation in its original form, negative 3x minus 2y equals negative 6. And I just, negative 3 times the x, so I plugged in my negative 4. I substituted it in there. Negative 3 times negative 4 is positive 12. Minus 2y equals negative 6. Then I just have an equation that I have to solve for the variable y. I've got to isolate it. So I'm going to get rid of this positive 12 by subtracting 12, but I have to do that on both sides. So now I bring down my negative 2y equals, and then negative 6 minus 12 is negative 18. Then I divide both sides by negative 2. And negative 18 divided by negative 2 is 9. So there is my solution as an ordered pair. The x is negative 4 and the y is 9. And that's how we use elimination to solve a system of equations.